Okay. Well, good afternoon, everyone. Thanks for joining this edition of the West Watch. This is Dan McAvoy from the Western Regional Climate Center in Reno, Nevada, at the Desert Research Institute. Thanks for joining the August edition today. I have a few background slides on the West Watch before we start. For any folks that are new, I'll quickly go over here what is West Watch. And this is a monthly webinar series that brings together mostly NOAA staff and partners from across the region. And we share information about climate observations and impacts all across the West and along the coasts. There are two formats that alternate each month. There is the format, the old format that we have this month, where we do climate and coastal overviews. And then there's a second format, which we had last month on atmospheric rivers, that is on specific topics. And I did want to mention that the recording for the July webinar is ready, but it hasn't been posted yet, and it should be posted to the website fairly soon. So a few housekeeping items here. We have one quick poll for the audience that should pop up on your screen here in just a moment. I'll ask you to answer that question. And not seeing that yet. Oh, here we go. Give attendees a few seconds to answer that. And the question is, have you attended West Watch previously? Get a sense of how many newcomers and how many previous attendees we've had. All right, thank you all for filling that out. It looks like we do have quite a few people, 38% that this is their first time attending the West Watch. So thanks for coming to check this out. And thanks to all the other folks who have been coming in the past as well. So we're gonna have 4 presenters today. Each speaker will get 10 to 15 minutes or so. There is a question box here at the right where you can put your questions in there. If timing aligns, we will try to have a brief Q&A after each speaker, and then hopefully at the very end there'll be time for more questions and discussions. This is being recorded, and the recording will be posted for the future, and there will be a post-webinar survey. And we really appreciate if you can provide some feedback on the West Watch for us. So today's lineup, myself, again, I'm Dan McAvoy at the Western Regional Climate Center. I'll be providing the climate and ENSO overview, as well as the seasonal outlook. And then our coastal ocean observing system partners will be after myself. We'll start from the south coast of California this time with Clarissa Anderson, move up to central and northern California with Henry Roll, and then to the Pacific Northwest with Jan Newton. And so we have a lot to pack in, so I'm going to jump right in and get started with the climate update and outlook. And so I'd like to start off with some of the recent temperature and precipitation anomalies. So this is showing data from the last 30 days. And on the left, we have precipitation as a percent of average. And then on the right, we have the mean temperature anomalies as a departure from average in degrees Fahrenheit. And so on the left, the browns are drier than normal conditions, and the greens are wetter than normal. And we do see a few patterns showing up here. California, there are very dark browns there, but this is typically a very dry time of year for California, so that's nothing too unusual. I'm sorry, the one pattern that has really been kind of one of the main topics of interest over the summer in the climate across the West is this slow or lack of a start to the southwest monsoon. And so I've highlighted sort of the main monsoon area there over the four corners. Really, Arizona and New Mexico are the main areas of the southwest monsoon. And some of these areas get the majority of their annual rainfall in about 3 months during that monsoon. And it started off very slow. Some places are less than 50% of average precipitation over the last 30 days. And it's also been extremely hot in the southwest. Extreme heat, and this is a lot of this is due to the lack of monsoon. So there's more sunshine, more warming of the surface, drier conditions, and so it's been extremely hot. Across the rest of the West, temperatures have been mostly above normal. There's been some spotty areas of below normal temperatures. The Cascades and to the west of the Cascades have been quite dry, as well as parts of the northern Rockies over the last 30 days, with some wetter conditions into the Great Basin. But I wanted to put this into more of a long-term climatological perspective, looking now at the July total precipitation and average temperature rankings from the West-wide Drought Tracker. And so on the left, we have precipitation. Again, the browns are drier and the greens are wetter. And so any of those darkest areas of brown is a record dry grid cell going all the way back to 1895. And so again, some of these areas in southwest Colorado, western New Mexico, eastern Arizona, parts of Utah have seen the driest July on record. And then it's also been very dry, July was very dry across the northern Rockies, where they've been in the bottom 10% of the distribution going back to 1895. Then on the right, we have the temperature rankings, and any of those darkest reddish orange colors is the warmest July on record. And so almost all of Arizona, big chunks of New Mexico, and some other isolated areas in the southwest have had a record warm July, and pretty much the rest of the West was much above normal. A lot of the areas in the top 10% of all Julys, with very few areas of cooler than average temperatures in July. And you do need to put these anomalies into perspective sometimes. And so this is now showing the July precipitation, but as a departure from average in inches. And what we see is that whilst that map was showing kind of crazy anomalies in California, the actual departures are very low because it's the dry season there. However, in the monsoon area, we see departures of 2 to 3 inches in the mountains and in southwest Colorado, or even greater than that. And so big deficits in July, and also large deficits in parts of the Cascades in Washington State, and then the northern Rockies as well. And so back to the heat, this has really been a big story, especially in parts of Arizona and New Mexico. Phoenix has set some pretty crazy heat records for July. These next two slides are courtesy of the National Weather Service Phoenix Twitter page. And so they set at the Phoenix airport, they set their all-time hottest monthly temperature on record ever at 102.7 degrees Fahrenheit. And this really shatters the previous hottest record, monthly record set in August of 2020 by almost 4 degrees Fahrenheit. And so it was just very extremely hot. Every single day of the month was above average, and about 7.2 degrees Fahrenheit above average for the month. And then they also provided these records. I'm not going to go through all of these. I've already mentioned some of them, but these records for most consecutive days at 110 degrees Fahrenheit of 31 days in a row, and then the next threshold of 115 degrees Fahrenheit, 17 days in a row with highs greater than or equal to 115. And the previous record was just 6 days back in 2020. So again, just blowing these other records out of the water. But in terms of contributions to human health impacts, the high temperatures do make a difference, but it's the overnight low temperatures that don't cool off as much that have a big impact. And so there were 19 days with low temperatures that were greater than or equal to 90, and they had a new all-time record warm low temperature of 97 degrees one night. And so it was these really, the combination of the hot days and then staying hot at night to led to a lot of these extreme health impacts. And so these are headlines from, and these aren't local to the Arizona area. These are headlines from national news outlets talking about the deaths and hospitalizations related to the extreme heat across the Southwest. And so this had big impacts. I think there is potentially some good news here pointing towards a return to the monsoon over the next week or so. The map on the left is from the Climate Prediction Center showing the odds or the probability of above or below normal temperatures, precipitation in the August 20th to 24th period. And we see those darker shadings of green in western Arizona into Nevada, Southern California, that are indicating about a 60 to 70% chance of above normal precipitation. So that's not the entire monsoon region, but that would be helpful. Then on the right is the longer range forecast outlook of the 3 to 4 week precipitation outlook, valid August 26th to the 28th. That continues to show green shading or higher odds for above normal precipitation across the monsoon region and larger areas of the western US. So hopefully that plays out. There is a tropical storm in the Pacific Ocean that could play into this and draw more moisture up into the West Coast to enhance these monsoonal surges. But that there's still a lot of uncertainty around that at the moment. And so with that heat and dryness in the Southwest, drought has expanded. On the left, we have the latest US drought monitor map from August 8th, showing large areas of drought across the Southwest and also the Pacific Northwest. There are some areas of D3, which is extreme drought in Southeast New Mexico, but larger areas of D2 and D1 across the region. And really these changes have come, there's been a lot of degradations. On the right, we have the change in the US drought monitor over the past 2 months or so. And we see those areas in the Southwest and the Pacific Northwest have gotten quite a bit worse due to the climate anomalies that I've been showing. And so in terms of the fire season, we're kind of in the middle of the fire season right now, depending on where you are at. And so the map on the left is showing the active large wildfires, so greater than 1,000 acres. And so this has been a relatively slow start to the fire season for some parts of the West, especially California. But those dots there on the map, they do align pretty strongly with the US drought monitor map that I just showed. So that combination of the dryness and the heat has been really drying the fuels. And particularly in the Southwest, in the monsoon area, the fire season's persisting longer than it would if it was a very active monsoon. And we can see those active fires still in Arizona, southern Arizona and New Mexico that would likely be extinguished if we had a more active monsoon. And I'm showing also on the upper right the fire potential outlook that was issued August 1, and it really did highlight Pacific Northwest into as well as parts of Arizona and New Mexico. So a pretty good job on that outlook. Moving forward, the wildfire potential outlook for September and October I'm showing now. And for September, the hotspots look to be the Pacific Northwest, primarily Washington and Oregon, Northern California, Western Idaho, large parts of Idaho, expected to have above normal wildfire potential. And then as we move into October, as we start to get in the wet season, particularly in the Pacific Northwest, it's kind of interesting to still see those above normal chances for large wildfires west of the Cascades. So that is kind of interesting as the wet season usually ramps up. I'm not exactly sure what was driving that, but that's something to keep an eye on. So now I'll quickly go through the ENSO update that was issued August 14th. All of the stuff on this slide is from the Climate Prediction Center. And so we are currently in an El Nino advisory and El Nino conditions are being observed. We can see the sea surface temperature anomaly map on the right, highlighting the ENSO region, showing those above normal temperatures, especially as we go further to the eastern portion of the ENSO region. And so the atmosphere is responding to this and is consistent with weak El Nino conditions. And it's anticipated that El Nino will continue through the Northern Hemisphere winter. And the odds are pretty high that that will happen. And so now I'm showing the forecasts from the IRI and Climate Prediction Center. On the left, we have the probabilistic outlook. So each bar is showing a season starting with July, August, September, and the reds indicate probabilities of El Nino. Grays are neutral conditions. And you can see over the next several seasons, near a 100% chance of remaining in El Nino conditions. And then the plume on the bottom right kind of shows the magnitude a little bit better that's expected. And most models agree that a moderate to even strong El Nino could potentially develop as we head into the fall and winter months. And lastly, I just wanted to share the Climate Prediction Center July through, that should say September through November outlook, not July through September. And this was issued at the end of July. The next outlook will be issued, I believe, next week. But this one is indicating higher odds of above normal temperatures across all of the West for September through November, and drier than normal conditions across Washington and Oregon, and continued below normal precipitation across the core of that monsoon region in Arizona and New Mexico. So with that, we will move on to Clarissa Anderson, unless Joe sees any questions for me in the chat box.
Yep, no questions as of yet, but for any folks in the audience, feel free to put those into the chat box at any time, or the questions box, pardon me.
Thanks, Joe. So I'd like to introduce Clarissa Anderson.
Thanks. Just realized I had not unmuted. Here we go. And thanks everyone for reversing the order today. I know we normally start with NANUS. I'm going to try to make this story as succinct as I can, but we wanted to go in reverse order to highlight this pretty massive harmful algal bloom domoic acid event that has been on pretty much everyone's radar who's near the coast lately. So I'm going to step through kind of how I was thinking of how everything unfolded and the way we were seeing it, which really started with noticing an abundance of animals stranding even as early as late May. And this is a smattering of the headlines that were coming in as animals were, mostly at this point, California sea lions were seizing on beaches. They were exhibiting these common symptoms of domoic acid poisoning. This is a neurotoxin that we've discussed many times in this webinar, and it's naturally produced. It's a phycotoxin, meaning it comes from algae. At first, nobody knew that that's what it was, but it was quite obvious that the signs were connected to DA poisoning, and that is because you see this kind of lethargy, but you also see foaming at the mouth, you'll see seizures, some erratic behavior. And we were being alerted to this early on, but as we went into June, the animals, it almost went up exponentially in the first and second week of June, such that animals were coming in, not just California sea lions and other pinnipeds, but we were starting to see quite a few dolphins. And that made this a really unique event in the number of dolphins that ultimately stranded. And in addition to that, we saw lots of aggressive sea lions. And so as you can see in some of the headlines here, where it says things like sea lions are biting people, it's not completely out of the ordinary to see erratic or even aggressive behavior in sea lions that are suffering from DA poisoning. However, to have 30 or more cases where people are landing in emergency rooms because of their encounter with these animals is highly unusual, but may also be explained by the fact that this was happening right in June and July as people are starting to flood to the beaches, especially for the 4th of July weekend. In the end, I'm definitely not bearing the lead here. The ultimate count we have now, and we're still waiting for numbers to come in, but throughout the marine mammal stranding network, we've seen a lot of animals come in, mostly from San Luis Obispo County down to the border at Mexico. And in that region, which is a relatively small region, if you look at some past blooms where we had this number of animals strand or die or have to be euthanized, we're talking about over 1,000 California sea lions and other pinnipeds, and we're talking about over 100 dolphins, mostly long-beak common dolphins. And there were other unusual aspects to this, a lot of pregnant females in the dolphin group, a lot of live strandings in the dolphin group, which is extremely rare. We also saw some pregnant females in the California sea lion group and some other males that normally would not come in. So looking at the data, I'm going to try to go through this quickly, but we had a few ways of looking at this at the time. We could look at our weekly harmful algal bloom sampling at the pier, but we only had the cell counts early on. We didn't have the domoic acid data, which has about a month delay to it. We did have the California harmful algal algae risk mapping system, which is CHARM. You're seeing it on the left here in an animation just for the outlook for risk of a Pseudonychia bloom. That's the diatom that causes this toxin. It did kind of home in on this region early on, but when we were looking at the weekly sampling, what we noticed is if you look at the solid lines in this time series here, we're really seeing that the peaks towards the end of May at sites like Cal Poly Pier, which is in blue, were actually for the kind of wrong size class of this diatom that would be the one we would think of as a concern. This is the less toxigenic size class. And it does really reach some marvelous peaks there as you go into June. We really don't see the super toxic size class emerge at places like Stearns Wharf. All the animals are coming into the Santa Barbara Channel region. We really see that tick up and it towards the end of June. So that's really interesting, and this kind of befuddled us. It really made me think this was an offshore bloom. We have animals that feed offshore, they feed in the subsurface coming in, but there is evidence that we could have had some of this begin near shore and maybe move offshore. The California Department of Public Health also does their own phytoplankton sampling. If you just focus on the red boxes here in these circles, you'll see that the more toxic group was abundant in places like Santa Barbara, LA County, Orange County, but never really reached that abundance level in San Luis Obispo, even though that is where we seem to see some of the earliest measures of this diatom peaking in our weekly shore station monitoring. So a lot of this just kind of confuses the story, and I think at the time we were all very confused. I'm certainly still convinced this was predominantly an offshore event. What you're seeing now is that same CHARM model, but this time looking at the risk of an event of the toxin itself. And over that time series, as you move into May to June, you're seeing the red intensify around the Santa Barbara Channel region, Central Coast, and on down into the Bight. And that was kind of the situation that we saw in terms of animal strandings. When we did finally see the nearshore domoic acid measurements that you're seeing here in this time series plot, the peaks didn't come until sort of, mid to late June. At Cal Poly Pier, the blue dot that you would see right around somewhere like 0.4 nanograms per mil of domoic acid in mid-May, that would have been an early sign for us that something was happening. It's not a level that we consider crossing a key threshold, but it is a level that would have alerted us, but we didn't have these data until a month later. So that is always a struggle with some of these analyses, that we don't have them quite in real time. But what we do have in real time is animal strandings, and they are particularly sea lions or a sentinel for these sorts of toxic events that do often have their foci somewhere offshore of the kind of most nearshore band. And so as we approached this, we knew we needed to get offshore and do some sampling. So we were able to get some NOAA event response funding to do that. A lot of the ships of opportunity were out of commission at this point in time, which was really unfortunate. Most of our robotic microscopes that we would have at the piers that would tell us in real time what the plankton were doing were also out for maintenance. So it was a challenging time for us. We worked with the marine mammal centers, who were having the most challenging time keeping up with this just incredible influx of animals, sometimes getting tens of 50, upwards of 50 calls per hour, trying to respond to animals that were in great need. So we've been working with them, trying to figure out how to get as much tissue as we can from the animals that came in, and where they were able to harvest some tissue, look at that for DA. We're seeing some incredibly high levels of domoic acid in the dolphin tissues that have been analyzed so far, probably the highest domoic acid ever measured in dolphin tissue. And this is interesting because last year we also saw some really high measurements in the sea lions, probably the highest we'd ever seen in sea lion feces from last year's bloom. Briefly, I'll just talk about what might be behind this. Of course, El Nino has been discussed a lot in the media. There actually isn't a great statistical correlation between these events in Central and Southern California and ENSO. However, we know this is happening. We know it's coming to our region, if not here already, and would suggest that maybe warm temperature or something along those lines is connected to these blooms. There is some evidence in the literature of that. However, I also want to get into some of the more nearshore data in a minute. Here's the California Underwater Glider Network, and what you're seeing here particularly in the time series on the right, is that correlation with the oceanic Nino index, where in the various El Ninos that we've seen in the past, there is a tight correlation, but often the Southern California region lags the equatorial Pacific a little bit. If you look at where we are now, there's very, very tight coupling. As the equatorial Pacific has warmed, so has the Southern California bight. This is a subsurface measure, of course. And if you're looking at that Hofmüller diagram on the left, what's important to note is while we have still been in kind of anomalously warm state ever since the marine heat wave of 2015, 2016, it has been cooling relative to that initial peak back then. But as we go into this El Nino, things are clearly warming. But what's happening right up against the coast is maybe a little bit different, and maybe tells more of a story about what's happening in the coastal band, where all of these blooms generally originate. And what you're seeing in the glider profiles here on the right is a really strong upwelling signature with anomalously cold temperature and high salinity on line 80, which is just around point conception at around the time when this bloom got going, essentially when we started seeing animals come in. And if you look at the shore station data, while there is a little bit of a warm anomaly at Cal Poly Pier, oh wait, that's Stearns Wharf in the upper left. I don't have Cal Poly Pier on here, but there's a little bit of a warm anomaly there towards the end of May for Stearns Wharf. But generally everything was really cool relative to background. We've got some pretty cold upwelling type waters that were going on through the months of May, June, July, starting to warm in August. And this held true with the fact that there was so much fog. It was clear there was a lot of upwelling. If you look at these two indices of upwelling, QD and Beauty being the biologically effective upwelling transport index, what I think I would like you to focus on is that in those bottom two bins where we have a red rectangle, that there was somewhat anomalous upwelling in the general region that we're talking about over this relative to the background average that goes back to the 90s for this index. And so I think we're looking at more of a situation of upwelling fueled blooms than we are of warming fueled blooms, but time will tell as we try to get into this. As the bloom was unfolding, we put out a web application to work with marine mammal folks, and we now have a bulletin that's about to come out that will give another deep dive into what we think happened. And so I'll leave it at that. Thank you so much for the time.
Thanks, Clarissa, for the great presentation. I guess we'll just do a quick check-in with Joe if there's any questions for Clarissa.
Yeah, we've got one here. Although ENSO models don't account for the uptick in algae blooms, is there a correlation between the weather events in late winter, collapse of the polar vortex, and the increased water temperatures?
There may be a connection there. I would have a hard time speaking to the water temperature connection with those vortices. I think where I've gotten more questions is about all the atmospheric rivers that we had in the winter and nutrient discharge, where I have a much harder time connecting nutrient discharge from the winter with some of these blooms, just given sort of the timing, the dilution impacts. We don't tend to see that kind of a lag in the system with respect to nutrients and algal blooms. As far as what's really driving some of the changes in temperature, I can't really say. Is it El Nino? Is it some of these other interesting phenomena in the North Pacific? I'm not qualified.
Thank you, Clarissa. So we'll move up the coast this time to the central region and let Henry Ruhl take it away.
Thanks, Clarissa. So moving up the coast, so the headlines from this will be that it's been getting warmer for about a month offshore, and it's just in the last week has started to come onshore, and that's really sort of the headline change of what's been happening recently. And so, yeah, so the figures you see here are from a recent paper published last month to include authorship from our Senkus community, Ryan Walter, at Cal Poly. And so the left panel shows temperature and upwelling and Pacific decadal oscillation, as well as instances of marine heat waves and also cold spells on the bottommost panel. And so this is one of the first papers, I believe, to look at this not only heat but cold spell phenomena in the California current. And what they found was some, on the right side, you'll see some interesting patterns between the decadal oscillation and the ENSO indicator and upwelling, which is shown on the y-axis of those scatter plots. And so it sort of summarizes in some ways what many of us might have thought conceptually, those of us that are looking at upwelling regularly, and where and when these cold snaps and heat waves might be occurring in relation to stronger or weaker upwelling, which then of course have onward relationships with El Nino. And so just in a week ago, some of us were contacted about the developing marine heat wave and the sort of centered around the border between California and Oregon. So from the San Francisco Chronicle, but also elsewhere. And here we have a blob, so-called blob tracker and heat wave figures from Andrew Leasing and colleagues in NOAA who are on the line today. He's on the line today. And so you can see very obviously the heat wave developing, and on the right side, you'll see the most recent figure that's available. And there's a pretty intense center to that anomaly, which you see there, and coming to 4 or 5 degrees above average, and also getting near the coast. And so when this article came out, we had a pretty close look in Senkus about, well, what was happening at the nearshore buoys and also at the coast, so coastal stations. And we were not yet seeing anomalously high values, but also appreciating that the time series for those anomalies to be referenced against is not as long. But we weren't seeing anything yet, but we are starting to see that coming into the fore. And there's also a marine heat wave tracker that is working globally at a slightly, at a fairly coarse resolution for the coast. But you can see there on the right, rather the left side, the global view, and you can see that the contiguous area of the sort of strong and severe area is pretty large at a global scale, although there's some areas of larger moderate value. And then on the right side, you can see a zoom in on the area in Senkus, and you can see on the bottom panel a time series that shows you sort of evolution of the moderate to severe categories and how long they persisted, and that also relates to that point, which you can see highlighted in the top panel. So this is a nice tool to get a quick view of the heat wave phenomena. And so coming on to the coast.
Hey, Henry,
Yep.
Sorry to interrupt. I think your presentation is getting cut off a little bit on the bottom and the right side. I'm not sure if there's a way to zoom out just a little. It's only a small portion of it, but it's getting cut.
Yeah, I'm not sure how I could go out of presentation mode maybe to do that, but that's the sort of next best.
Yeah, I think that'll probably be, that's good.
Yeah.
Thank you.
Yeah. So yeah, so that you can see moving into the shore stations, the time series here is the last 180 days, going from Trinidad and Humboldt area to Bodega Bay, to the southernmost being the Moss Landing rainwater, seawater intake here in the area. And so it's only really in the last week that we're starting to see that the anomaly turn into the warm phase, but also the Trinidad station, we don't have data from the last week or so, unfortunately. Then when we move to the NDBC buoys, which are a bit further offshore, so about 8 or more miles offshore, you can see in the last week this warming is starting to occur there too, and it has happened earlier in the year. And then when we look at our glider network, so this is a glider running offshore Trinidad, and we have this glider visualization showing the last section that occurred, and about in the middle of that section where that red dot is on the map, there's a profile that was peaking at about 18 degrees at the surface. And when we look at a longer term record of that glider and the heat anomaly from that glider, at 50 meters depth, which is very similar to the sort of Southern California heat index in its calculation. You can see over the last decade when it's been anomalously warm and where, and of course now in 2023, it's been mostly cool, and you can't really see it in the, I'm sure in the online version, but there is a sliver of warming starting to creep up on that figure, but nothing major yet. Right, and so moving down the coast to the Monterey glider line, so that here we have temperatures from May, June, and July, and their anomaly on the bottom row. And so it has been warming consistently since we've had the last Westwatch update. And what you'll notice in the bottom right panel is the scale of all of these figures. It's important to note that they can change between the months, but they increased to about 3.5 degrees C as the peak on the bottom right anomaly, and that anomaly is subsurface. So that's I think somewhat unusual. I mean, it can be there other times, but it's particularly noticeable there and well structured in the sort of offshore 100 kilometers to about 300 or so. And so we've had a look at upwelling in the Southern California update, and you can see in the top panels the last several months, and so that this is still showing generally slightly higher upwelling and biologically effective upwelling transport index outcomes, and so that, but they are pretty moderate. I'd say they're pretty close to the nominal value. And having a look at the multivariate ocean climate index, we've presented this a few times before. It's kind of an amalgamation of several data streams to include the buoy stations that I had been showing, a broader network of those, shore station data on sea level, several other forms of data, plus the several of the climate indicators, including the multivariate ENSO index and PDO that we've often referenced, as well as the Northern Oscillation Index. And the headline there too is that things are pretty nominal, but they have sort of tipped above the zero line in the index, but nothing substantial, as it were. And this, importantly, does not yet include July or August. So this is April, May, June. It's calculated on a seasonal basis. But again, for Northern California, it's just tipped above the zero. And then also for Central California, just tipped above the zero here. And so to close out, we've been fortunate on the Central Northern California coast, knocking on wood, that the harmful algal blooms have not been substantially impactful. We did have some HAB activity in the San Francisco Bay that has since quieted down. There is a red tide in this area here on the Central Coast in Monterey Bay, but also so far no substantive consequences on marine life, but we're keeping an eye out with our HAB experts. And similarly, waves is this, it's a quiet time of year generally for waves, but it's really made plain here by the time series on the left side for our CDIP stations, and the wave spectra there, so really very little above 10 feet, all the way even up into Humboldt. And the wave model data is similarly showing pretty mild conditions. And so with that, I will finish and pass it over.
Well, thanks for that, Henry. We'll just see if there's any questions right now.
Yeah, we had one comment from Andrew Lessing, who got a shout out in Henry's comments, that the SST anomalies are very warm along the Central California coast to the Bight from early June to mid-late June. And that's very consistent with the story in the paper that Henry was showing in terms of the mechanism. But no question there for you, Henry.
Thanks, Joe. So we'll continue up the coast to the northwest with Jan Newton.
Hi, everyone. Good to see you. So I'm going to put this in present mode, and hopefully you can see it, and I'll turn off my video. All right, how's that look?
It looks good to me.
Great. One to many. Well, hi everyone. So it's been busy days for NANUS as we celebrated our 20th anniversary down in Astoria last week. And just when I thought life had sort of calmed down and returned a bit to normal, I was invited to hear Vice President Harris's comments this morning in Seattle to commemorate the 1 year of the signing of the IRA and its focus on climate. So, anyways, just kind of a recognition of a lot of things going on. Okay, oops. So here is the NANUS update on behalf of the Marine Pacific Northwest. So before I start with showing you climatologies, in the Northwest, we've been really inspired by this paper by Dylan Amaya, who said that when we look at marine heat waves and when we look at anomalies, we should really be thinking about what we're comparing. Oops, this keeps doing that. All right, and so here in his paper are two, what he calls dueling definitions. I don't call them dueling, I call them different. And I think they're different and I think they're both useful. I think it's really important and useful to understand how hot or warm conditions are relative to way back then. And for us on the Pacific coast, it would be before the blob, the first blob of 2013. Equally important is understanding hot or warm relative to now. And so a shifting baseline where if you don't shift your baseline, everything will look like a marine heat wave. I think these help managers and society answer two very different questions. So with NANUS, what we did is we decided to produce both of these. And so I've been showing you a climatology field. Oops, hang on, cancel. I've been showing you a climatology field and now we have two. And so for the satellite, we have 83 to 2012 as our fixed and 93 to 22 as our shifting, because as we go along, that will be a moving boxcar. And so if you look at these two pictures right now in this year, you don't see an awful lot of difference, but I want to, just throw this out, and I think it's important for our community to be considering. So this is the picture in May, and you can see there's a little more red in the fixed. All right. Here is the picture in June. We are seeing, again, similar pictures, but we're seeing the dissipation of the genesis of the El Nino, though the warmer waters in the Northeast Pacific well off the coast. And these are monthly averages. So here is the picture for July, and you're seeing it much, much closer to the coast. All right, so what is the marine heat wave tracker actually showing us? Henry showed this. Alistair Hobday and colleagues made an actual calculation of persistence and magnitude to define what a heat wave is and its category. And you can see that as of the 9th of August, this was the picture, still somewhat off the shore, though you see this little inland venture there off of the southern coast of Washington. So that is the actual prescribed value for a marine heat wave as internationally defined. Let's ask what the buoys are showing. And so here is an NDBC buoy off Washington State. The black line is the normal, pink 1 and -1 standard deviations, and red +2 standard deviations. And then of course the blue is our real-time observations. And you can see it is well above 2 standard deviations warmer, and right up there, this is a 45-year record, and all the gray lines are different years. But you can see it's up among some of the highest, though not the highest. But this is certainly getting people's attention, and both our NPR KUOW radio station and then the Seattle Times wrote articles about what was going on and really examining what Washington and Oregon can expect. So let's look at some of the other buoys up and down the coast. So you can see they're color coded from Cape Elizabeth in the north all the way to St. George in the south. And as we always see, and as we always expect, the coastal picture is a lot more dynamic. I'm sure due to the winds and upwelling, downwelling, cycling. We did see that heat dome in May, but then since that point in time, things relaxed and came closer to normal. But as you see in the last month or so, it's been ticking up, and they're even at Cape Elizabeth across this 2 standard deviations, and at the Columbia River Bar as well, not quite as pronounced as you go farther south. So I mentioned being at Vice President Harris's conference this morning because it was a little interesting. The governor asked me, anyway, we happened to run into each other, and he said, I went surfing and it was warmer. How much warmer was it? And I said, well, you know, yeah, it's 2 standard deviations. And he said, what is that in Fahrenheit? It almost jammed my brain. But I was so happy that I had these slides. All right, so what are we seeing in Puget Sound? A bit of a mixed signal in these profiling buoys, some warm, but some sort of less than warm. The salinity continues to stay higher than normal. We've been seeing that consistently for years now. In the summer, we have these higher than normal, according to our 11-year climatology, not nearly as long of a time frame. And then oxygen is a bit of a mixed signal. So what I want to get to is the blooms. And what I would say, listening to Clarissa, listening to Henry, and listening to our colleagues from Oregon WDFW, and then from a buoy we have, these blooms are very localized, and people are seeing different conditions in terms of the toxic blooms. So on Oregon, it's been described as a tale of 2 coasts, which with Southern Oregon not having the toxic bloom and Northern Oregon having that. Up in Washington, we are fortunate that Stephanie Moore and John Mickett's ESP offshore has been measuring domoic acid in near real time, and you can see a rather large spike there that it measured, but then it came back down. So we're going to continue to observe this and see how that develops. So with that, those are some conclusions. I know we're pressed for time, so I think I will just summarize the headline that Henry said. We've got heat, and it is present on the coast, though not as strongly as offshore. Puget Sound has a bit of some mixed signals right now, and the HABs continue to be very localized, but are something we're of concern to watch. So with that, I'll say thank you. And how do I hand this back? There we go.
Thanks so much for that, Jan, and thanks to all the IU's presenters. It's really great seeing all this new technology to track the marine heat waves and the blooms, and seeing that unfold in real time and how valuable that information can be. We'll just maybe check in with Joe on questions. We do actually have about 10 minutes left. So there can be time for discussion or questions if folks are interested or have any thoughts or any comments or anything they'd like to say.
I could just say I was trying to answer Andrew's comments in the thing, but I don't know if they're going out. It's like I don't see the answers. I don't know if that's just GoToMeeting or a me problem. But
so you sent him go ahead, Joe.
I was gonna say, yeah, I think those may go just directly to Andrew for those.
I don't know. Andrew, are you there? It says you're offline, Andrew. I don't know if you can talk, but I wanted.
I can see the question.
Well, it's a healthy discussion to try to figure out how you make sense of these anomalous warming that we know has kind of really been a persistent case in the North Pacific since the last large marine heat wave that started in 2013. But then you can also have really strong upwelling up against the coast. And I do strongly feel from what I've seen so far that this DA event, at least in Central and Southern California, while it may be happening at the same time that a marine heat wave is coming in and El Nino is aligned with warming temperatures in the subsurface, it does appear as though there was really cold water and enough nutrient input coming from upwelling in the more, I hesitate to say near shore, because there's near shore, which is literally the coast, literally the coastal band where we have some sensors, and then there's that near shore swath. Where's the upwelling? What's fueling these blooms? And I think it makes for a really complicated story, and it's neither the marine heat wave nor just upwelling, and there's probably some combination where these marine heat waves have led to strains and species that are really toxic to persist for the last 5, 6, 7 years. And when you do have a pulse of upwelling, now those strains really get going, and they get going in a vigorous fashion.
Clarissa, I think that would be really interesting to think about, and I agree with you. We use nearshore in many different ways, or offshore and closer to shore. It is a little confusing, but it would be interesting in Oregon just to see if that could explain the differences that they're seeing. That would be interesting.
We did have one question pop up, and I'm actually going to see it's from Ann Mullen, and I'm going to take her off mute so she can ask it herself.
Okay, you can hear me?
Ann. Yeah, we can hear you.
I was wondering if the fishing communities were seeing changes in species, either because of the domoic acid or the heat.
I mean, as far as domoic acid goes, changes associated with domoic acid, not exactly. We're still trying to figure out what the vector for that bloom was. Was it anchovy? Most likely. Could have had a squid influence, but mostly it's a lot of the guts of these animals are empty when you finally go and do the necropsies, in part because they stop feeding or they regurgitate. So it makes it hard for us to track which animals are the cause of it. But in terms of shifts due to temperature, there probably are some. Jan and Henry might be able to comment.
I haven't heard anything, and we did just have our Big Nanus community meeting, so people might have said something. Oh, we had a very cute last slide. It was an aerial of all the people there, but I forgot to advance it. So I don't know of any.
Yeah, I checked in with Rafe Cadella yesterday on HABs, he's a regional expert, and yeah, he didn't mention anything about it and suggested it was sort of fairly quiet by comparison to the challenges that Southern California's faced. So yeah. I can also just maybe reference Andrew Leasing's comments in the chat. So that, yeah, one of the challenges with these is that there are several different tools out there, and they have different reference periods and sometimes even more other kinds of issues about how those tools are different. And so I think it is worth considering how to more consistently communicate what these things mean, and particularly he was thinking maybe perhaps the severe and extreme categories might be a particular the language, but also telling the difference between them, I expect, is a bit woolly, because in part because what we're talking about the difference between the very close to the coast, and then as you go offshore, there's different tools that have different skill in those areas, and yeah, so different things to factor in there. And it's of course something that it may continue for quite a while, according to the outlook, as it were. So.
Did get another comment. Troy, I'm going to try to take you off of mute. That worked.
You hear me
There
now?
we go.
I think
Yeah.
Yeah. Just somebody had asked about observations from the fisheries. So we have been starting to see more warm water species like Dorado and bluefin tuna show up in some of our recreational fisheries in Oregon, and the albacore are very close to shore, almost certainly driven by the heat coming in.
Thanks, Troy. We actually got another comment that said that Double Down said there's a number of Dorado being caught by sport fishing boats in Oregon.
So I have a question. What do we think, our crystal ball? Certainly El Nino is going to continue, and as the season wears on and upwelling yields to downwelling, we often see the advection of the warmer than normal conditions come onto the coast. So it could be a really interesting fall. Anybody have any thoughts on that?
Nothing's coming in, but I'm actually really interested in the answer too, Jan, because I feel like there's a lot of extrapolation about the changes in precipitation or temperature that we should see this winter. And I feel like those relationships to ENSO are small, relatively subtle changes in the odds. Whereas I think sometimes what we've seen perhaps in the ocean has been maybe a little more variance gets explained. I may be incorrect about that, but that may be a better bet, you know, when we're thinking about what are the impacts of ENSO and kind of the North Pacific region.
I don't know, every ENSO is different. The ecosystem impacts seem to be different every time. It makes that predictability really hard. I mean, even this sort of, I would say maybe a somewhat of a misconception that El Nino and precip in Southern California are so highly correlated, when I don't think it bears out in statistics, is the same feeling for HAB. So when we see El Nino sort of rising at the same time a large DA event happens, the obvious answer is that it's El Nino. But I think when you dig a little deeper into what's happening in the water column, it's not quite here enough to have that sort of influence, I don't think, on blooms. But I think this is a question the research community is grappling with.
And I think we learned from the last strong El Nino in 2015, 16, that it doesn't necessarily mean a very wet Southern California, Southern tier. Even if it's a very strong or one of the strongest El Ninos on record, you can still have wildly varying weather impacts and coastal impacts as well. So I appreciate that discussion. I also appreciated the discussion on the choosing the climatology for the marine heat wave definitions, as that's something that the climate and drought monitoring community has been discussing for years. The World Meteorological Organization likes to use 30-year moving windows, but still with some of the drought monitoring, we like to use the longest record that we can have, the full period of record of a data set. So that gets at that fixed versus moving window. And there's been some recent kind of high profile papers highlighting that exact thing, where maybe we should be shifting to these shorter climatologies to account for the non-stationarity. And it's great to hear these discussions in the marine community as well.
Yeah, I was really inspired by Dylan et al.'s paper. And I think, to me, what's important is it's not one thing or the other thing. They're different. And I think we should be thinking about how to portray that with our data sets, that we can capture that, because it is a very different question. I gave a talk to Clivar, who was fortuitously having their meeting in Seattle. A lot of people coming to Seattle. And I think they were really focused on, as a scientific body, what should they weigh in on? And I really tried to put forth the concept that our user groups have many different questions, and whether you're a manager who cares about fish, or whether you're a climatologist trying to look at, this thing, you would want a different view. And I think as long as we define what we're doing, I think that's really helpful.
And I have two things I'd like to say before everybody signs off. One thing is, we're having a discussion within IUCE and with our weather service colleagues about potential decommissioning of various NDBC yellow buoys. If you know about these or have use cases you want to give to us to help relay to leadership at NOAA to stop decommissioning of some of these buoys, let us know. The other thing I wanted to say is the Eastern Pacific Ocean Conference is September 24th, 27th. It's something we all appreciate. I think we get meteorologists like Dylan and Maya coming to that meeting, and we really encourage that if you're ever interested in registration deadlines coming up. So let me know if you want more info.
All right, well, we are just crossing over 3 o'clock. So thank you, everyone. It's been a good discussion. Great West Watch. And thanks, Joe and look forward to seeing everyone else again in September.
Thanks, everybody.
Thanks, everyone.
Thank you.